Good morning. Today we're going to talk about how to solve systems of equations by using substitution. So we're going to solve systems of equations, which is just more than one equation at a time. Systems of equations using substitution. So we're going to use a different method. So in the past couple of days, we used graphing to solve our system of equations. And what we did is we graphed the two equations on the same coordinate plane to see where the two intersected, where the intersection was. That was our solution. So for example, let's see, we might have had a line that went like this and another line that went like this, but the actual solution itself would have been that ordered pair where the two met. So let's pretend this is like 3, 2. So x equals 3, y equals 2. So for every single problem, there was two parts to our answer. There was an x answer and there was a y answer because it was an ordered pair. Well, sometimes solving by graphing doesn't work so good if we have super big numbers. Nobody wants to graph an equation that has a y-intercept of 1,712 because that would just be take forever. So we want to be able to use different methods to be able to solve these equations, these systems of equations. So today we're going to talk about substitution. And substitution is where we are going to sub in equivalent values. It's kind of like an evaluating problem. So let's use this. Let's do this up here. Let's say I had x plus 2y minus 7, and I said, okay, so evaluate it when x is 2 and y is -3. Well, how would we do that? We would actually plug 2 in place of the x. So we'd go here and we put 2 in right here. And then we would put -3 in for the y. And then we would use PEMDAS in order to solve this. Now, the reason we could do that is because if we were told, we know that x is equal to 2, they're equal values. So it doesn't matter if I use x or if I use 2, they both stand for the same value. That's what we're doing today in substitution. It's not going to be quite that simple, but it's going to be close. So here's what I'm going to do. I'm going to go ahead and get rid of this stuff here, get this out of our way before we start. And I definitely want to use a different color. So let's change it over to blue. Okay, so we have this problem number 1, 2x plus 8y equals 20. That's our first equation. The second equation is y equals 2. Well, we already know what the y is, right? We're supposed to find x. X equals y equals. We need to have both of those things solved out for in order to be done with this problem. We know one of them. We know y is 2. Well, if y is 2, then I can go back up here and I can replace that y. Remember, if y is equal to 2, I can do a substitution. I can take that y out and I can replace it with 2. Now, how does that help us out? Well, when I replace the y with 2, then the only variable I have in my equation is x. And if all I have is one variable, I can go ahead and karate chop and solve this problem out for x. So I have 2x plus 8 times 2 is 16. Now it's a two-step equation. So I'm just going to subtract 16 from both sides. I get 2x equals 4. I divide by 2, and x equals 2. X is equal to 2, y is equal to 2. All right, so let's try another one of these. This time we are given that x is equal to 5. Well, good, because now we already have half of our answers. We just have to find y. Okay, so how do we find y? We're going to use that other equation right here. We're going to take that y, whoops, not the y, we're going to take the x out because we know what the x is. So that's our substitution. We're going to make that sub. We're going to sub in 5 for x. It's kind of like in basketball, somebody needs a break. We're going to sub somebody else in for that person that needs to come out. All right, so now that we subbed in 5 for x, we now only have y in our equation. And if we only have one variable, then we can go ahead and karate chop and solve it out. So I have 2 times 5, which is 10, plus y equals 10. I'm going to subtract 10 from both sides, and y equals 0. Normally I'd say, whoa, wait, y equals 0. Is that a valid answer? You know what? I can always check my work. I can go back up in here, 2x plus y equals 10. Let's see if it actually works. X is 5, so let's plug that in here. Y is 0, so plug that in for that. And is it true? Is 2 times 5 plus 0 equal to 10? Yeah, it is. So this is the correct answer for this problem. All right, so that is when we know one of the variables. The next couple of problems we're going to do is 3 and 4, and we don't know what those any of those variables are, but we do have one of the variables solved. So if you'll notice, this one is y is equal to 2x. So we already know what y can be replaced with. Y can be replaced with 2x. So we're going to take that first equation like this, and we're going to say, what? We're going to do a substitution. We're going to take y out of the game. We're going to replace y with something that's equivalent to y. So we're going to put in 2x right here. Now, looks more complicated, but we still only have one type of variable, which means we can go ahead and simplify this out and solve it. So I have 5x minus 2 times 2 is 4, so minus 4x equals 3. 5x minus 4x is 1x, so x equals 3. Now this is my first part of the answer. I'm not done yet. I still have to find y. So how do I find y? I'm going to go back into this problem, this equation right here. I have y equals 2x, but you know what? I know what x is now. X is 3. So I'm going to put 3 in for x. I'm going to do that substitution. So now I do the math and I get y equals 6. Okay, so here's what I want you to do. I want you to go ahead and pause this video right now. And I want you to do example 4. All right. So when you get done trying out example 4, then you can play the video and you can watch me do it and see if you did the steps correctly. Okay. So pause it right now, and then you can play it again after you're done. All right, so I am assuming that you have already solved this out. Well, we have x equals 3y. Right there, that tells me that I have x equal to something, so I can replace the x in the other equation with 3y. So I'm going to take this x and I am going to put 3y right here. So now I'm going to add the two together. 2y plus 3y is 5y. So I have 5y equals 15. So to get y by itself, I'm going to divide by 5. That tells me that y is equal to 3. So I have part of my answer, I have half of my answer, but I still need to come up with the next part. So I need to go ahead and replace the y up here with 3. So now x equals 9. So if you got x equals 9, y equals 3 when you did this on your own, then you got the right answer. Okay, now it doesn't always look like this. We're going to skip, let's see, let's go down to, we're not going to do number 6, so we'll cross that one off, but we are going to do number 5. Whoops. This looks a little bit different because y is equal to x plus 9. So we need to replace the y up here. So we have 4x plus y equals 19, but because this is set equal, y equals, whenever you got have it solved out for a variable, that's what you're going to replace, that's what you're going to substitute in for. So we're going to take the y out right here, and we're going to replace it with x plus 9. So we're going to simplify this side. We have 4x plus x. Those two are like terms, so we can put them together and we get 5x. So this side simplifies to 5x plus 9 equals 19. So now we're going to subtract 9 from both sides. We bring the 5x down, and that equals 10. So now we're going to divide by 5. So x equals 2. So I've got half of my answer. But now we have to go back into one of the equations. Doesn't matter which one, but I'm going to tell you what, this one's easier than the other one to solve for. So we know that x is equal to 2. So I'm going to put 2 in for x. And that's going to tell me that y is equal to 11. So that is the solution. So that means if I graphed these two equations on a coordinate plane, the point of intersection would be 2, 11. Okay, so let's go ahead and do let's do number 7, and then we'll do number 8, and then we'll be done. Okay, so we have 2x plus 8y equals 20. Are either of these variables ready to be substituted for? No, we've got to use this guy. X equals 2. So that means we're going to take that x out, because whenever you substitute in, you have to take the other guy out. So we replace the x. We take the x out and we replace it with 2 because they're equal. So 2 times 2 is 4. 4 plus 8y equals 20. So now we have a two-step equation. Our job is to solve for y. So we subtract 4 from both sides. We get 8y equals 16. Divide by 8. And we get y equals 2. Well, we already knew that x equals 2. So we have x equals 2, we have y equals 2. We're done because we have both variables solved for. All right, so the last problem we're going to do is problem 8. Okay, so I have a y here, an x, here, a y here, and an x here. And the y is set equal to the rest of the problem. So that is going to be our substitution. That's going to be the value, this right here is going to go in place of the y in the other problem. So we have y minus 4x equals 15. But we're going to take the y out. And we're going to replace it with 6x plus 11. So I have 6x plus 11 minus 4x equals 15. On this side of the equation, I have like terms. I have 6x and I have minus 4x. So 6x minus 4x is 2x. So I have 2x plus 11 equals 15. So remember, when you stay on the same side of the equation, you just add or subtract as normal. All right, then we subtract 11 from both sides, and we get 4 over there. We divide by 2, and we get x equals 2. But we're not done. We now have to use this y equals 6x plus 11 to find our y. So we're going to plug 2 in for x. So 6 times 2 is 12. 12 plus 11 is 23. So y equals 23. I should maybe check this because that's really, really large. Okay, so let's try it out here. Hold on a second. I'm going to clear this out right here and right here. And what I'm going to do is I'm going to use that other equation, y minus 4x equals 15. And remember how I solved, okay, so x is 2 and y is 23. So that's 23 minus 4 times 2 is 8. Does 23 minus 8 equal 15? Yep, this works. So that really is my answer. Okay, so today for your homework, you are going to do the 6-2A worksheet that's posted in Schoology. That's going to be your homework. And there is a coloring part to it that you can do, but you don't have to do it. So if you complete the problems, I'm not sure how many there are. Hold on a second. Got it right here. There's 15 problems that I want you to try to work out. You're probably going to have to use some space on a notebook paper to be able to do these problems because it does take a lot of space. You saw the work that I had to show. This is not something that you could just look at and say, oh yeah, I know what the answer is. You have to work out the problems. Okay, so good luck with this. And remember that the after school Zoom session for help is going to be at 2 o'clock today instead of 3 o'clock, so that those of you who have after school activities can get to those on time. That is all I have for you. Have a great rest of your day.